This is the P3 Block 1 webinar to support the delivery of the Glasgow City Council Numeracy and Mathematics Progression Framework. If you haven't already done so, please join the Microsoft team where you will find all documentation related to the delivery of primary maths. The team code is displayed on this slide, and in this team you will find, as well as core documentation, that there are folders and channels available for you to collaborate with colleagues delivering the same primary stage as you. This slide outlines what's staying the same or is familiar from our previous documentation and what's changed. So, as with the Glasgow Counts framework, we have documents which outline all the content to be covered by each primary stage in an annual overview. The CPA approach is still underpinning all of our teaching, making sure that we're using concrete strategies followed by pictorial examples before moving on to abstract approaches when we're introducing new concepts. We will still have a strong problem-solving focus through our teaching and still have those high expectations of fluency with mental strategies through number talks and lots of mental agility exercises. Any resources that you've used to date will still be highly relevant and useful. And in terms of what's new, really, we've just got a new structure for the delivery of our teaching. So the annual overview is then split into 6 blocks of teaching, each block lasting approximately 6 weeks. You're teaching bite-sized steps through each block such that in a spiral approach we're revisiting core number concepts every block. There will be end-of-block assessments available for you to use should you wish. And aligning with those blocks, you will find there are also populated medium-term planners with suggestions for learning intentions. You'll find that conversely to our previous documentation, we do specify particular strategies as being age and stage appropriate for an on-track learner. So you will find there is a progression in the delivery of various strategies for calculation. And we also specify a number fact progression in terms of number bonds and times tables recall. The annual overview then looks something like this. The yellow highlighted section is the title for this annual overview. It explains what stage it is and which level of the curriculum for excellence it's aligned to. The green highlighted section is indicating the headings for the 6 blocks, which gives you an estimated couple of months of the school year in which to deliver those teacher points. Down the left-hand side in red, you've got the organisers or the areas of the maths curriculum that are indicated across each row, and then the blocks of teaching are running vertically down the page. So, for example, the area highlighted blue is indicating the teaching points for block 2 of this progression. Alongside that, you have our P3 block 1 overview, which zooms in then on this block. The teaching points from the annual overview for block 1 are sitting in the central column there with the highlighted yellow heading. To its left and right, you will find the teaching points that are before and after the core teaching in that progression, so that you can provide support and challenge for those pupils that are working within a few months of an on-track learner. You will find that there may be pupils who are working much further before in the progression of learning developmentally, in which case you may want to look at the P2 overviews or even back to primary 1. And this is exactly the same as we would have used the trackers for in previous years. In addition to that block plan, on the same document, you'll find a suggested list of learning intentions which would enable you to cover the teaching points over a 6-week period. That's been provided to show you a few different things. Firstly, how quickly you will move on from concept to concept. So in the primary sector, we're used to potentially spending a full week, if not more, on addition or subtraction. You will find in these suggested learning intentions that there's only space for you to spend a couple of days or at most a few lessons on a particular area of maths, but that's because we're only teaching a small part of the progression of skills each block, and knowing that in 6 weeks' time we're going to come back to that and add on the next part of the progression. The learning intentions have been written to reflect an awareness of current planning trends. So the fact that most teachers will be running core number topics alongside some beyond number teaching. And we know that in many job shares, that is a practical way of the division of labour between two teachers who are sharing the same class, that one partner may be focusing more on core number while the other is more responsible for the teaching of beyond number topics. So this reflects current practice in that sense. The learning intentions you will see are very child friendly in that they are straightforward and short and don't include any great specifics in terms of strategies, etc. That's intentional, and we would expect those specifics to be sitting in your success criteria. And therefore you can be differentiating that success criteria. The aim is to have one learning intention for everybody in the class at whatever level they are engaging with that concept. So we are learning to add. It's perfectly sufficient, even if we've got the pupils in the class working at early, first and second level. We can all be engaging with addition at whatever level is suitable for us. So I'm going to take you through the core teaching points. I'll be talking them through in terms of the block from top to bottom, but as ever, these teaching points will overlap and complement each other, and so whilst you may be teaching a distinct lesson on any one of them, you will find that they naturally reoccur. For example, any of these teaching points in the first organiser, which is number system and number fact recall, these will naturally reoccur and be revisited when we're looking at any calculation skills as we move on through the block. So we may be spending distinct lessons looking at partitioning, but we'll also be using those skills when we move on to addition and subtraction and so on. So let's move through and that will become clear. So in terms of number system fact recall for primary 3, we are building on their understanding of 2-digit numbers, which has been the focus of primary 2 in this progression. We're still wanting to use concrete materials or their digital equivalents, as you can see on the screenshots there, to model the makeup of now 3-digit numbers, because we're extending that confidence in the number system up to 1,000. The online tools that you can see screenshots of on the slide there and have the links to those tools if you're not familiar with them are really helpful for modeling these sorts of partitioning skills on the smartboard. They can also be used on iPads, and at the very end of this presentation you've got a QR code placemat that can be helpful for that in terms of having those available in caddies on desks and so on. If they are using them on iPads, you can then use markup to screenshot and share them, drop them to the teacher and so on, depending on how familiar and what skills your pupils have to do that. These are all really useful, but in terms of the concrete materials, they do need experience of that before moving on to using digital versions of them, so they know what those images on the screen are in place of. And obviously, confidence and fluency with partitioning is really at the heart of our formal column algorithms much further up the school. So our addition and subtraction column methods are completely based on hundreds, tens and units, and keeping those columns tidy. So understanding this concept really deeply and fully stands pupils in really good stead to tackle those abstract methods later on. So although we're looking at numbers beyond 100 for those first two teaching points, the third one is a new skill in terms of looking at subdivisions between marked points on the number line. And so for this, we're only looking at numbers up to 100 at this point. MP2, they will have done lots of work in placing numbers on a number line where the increments are already marked, so effectively putting missing numbers onto a number line. But here they're having to use their number sense to subdivide those increments. So the basic skills we're teaching here are for pupils to look at that number line, understand the range, so where we're starting at, where we're going up to. This example, we've got a number line from 0 to 100. We're looking at the increments we've got marked. What do we know here? So we've got it divided into tens. And then if there are increments marked and they know what they stand for, then looking at the numbers they're being asked to place is an estimate of where those numbers are sitting between the marked increments. And they're using their knowledge of the number system to decide how close to a labelled point it should be placed. So if you look at those arrows that are pointing to the number line there, we are wanting children to think, well, I know that 5's in the middle, thinking about those midpoints. That arrow there that's between 0 and 10, if I mark the midpoint in, I think that's more like an 8 than a 7. And similarly, if we look at the second arrow that's sitting between 30 and 40, I think that's probably more of a 37 than a 38, that sort of discussion. And ultimately, it's not super important that they're exact with this, but ultimately we're building skills so that if they ultimately are presented with a very challenging, completely open number line, as in that bottom example there, which is only something you do after lots and lots of input and practice, they would have those strategies to subdivide that up. So looking at that range being 0 to 100, let's mark 50 on. Could we mark the quarters on, 25 and 25? And that's where we want them to get to as they progress. The online game there at the link is a really useful modelling tool. You can manipulate it in lots of ways to change the number line that's provided, and then we can model that through, and from it model and co-create success criteria with the pupils about finding those midpoints, etc. So moving on to estimating by rounding. Rounding is a really related skill to the number line work we've just mentioned. When we are rounding, we need a mental number line to visualize where our target number is in relation to the increments of 10 or 100 if we're rounding to 100. In P3 here, we're looking at rounding to the nearest 10. So pupils should see rounding modeled on a number line as shown in those first pictures top right there. It's important to practice rounding both 2-digit numbers to the nearest 10 and 3-digit numbers to the nearest 10, because pupils frequently make the mistake of rounding to the nearest 100 if it's a 3-digit number, because they want to round it, they want to have zeros at the end. And so the way to scaffold that is to do lots of practice identifying the tens, or the sequence of tens beyond 100. They'll be used to counting in tens up to 100, but maybe not from 270, and being able to say 270, 280, 290, 300, and so on. So you can consider those counting routines as part of daily retrieval practice, or in those little moments of lining up or tidying up or whatever you're doing. And if we can embed that idea of counting in tens all the way up to 1,000, it helps them with this process, because ultimately to round any number to 10, they need to identify, as in that top right picture, identify the multiples of 10 that are before and after that number. And then when they've got those multiples of 10 before and after, they find the midpoint and decide whether the number that they're interested in is before that midpoint or after the midpoint. And we teach them that the exception is if we're right on the midpoint, we're rounding up. Okay? When that's secure, we can use our rounding skills then to make estimates of calculations. That's best taught during calculation lessons, because the whole purpose is to give the pupil a strategy which helps them know what approximate answer they're expecting. So by estimating something before we work out the exact answer to a calculation, pupils can be confident about the reasonableness of their answer. And although that may not be as necessary at this point in school, where they're working with whole numbers only and quite low values, actually as they move up and start working with more abstract numbers like decimals, it really helps if they've got a really clear estimation process, so that they know whether they're expecting their answer to be in hundreds or thousands, etc. It's quite common for a rhyme to be used to help pupils remember the rounding rule, and that's fine if it helps, but be mindful that without the visual of a number line to support it, their conceptual understanding will be poor and the knowledge won't be secure in the same way. So both things. And our last teaching points in terms of number system and fact recall relate to the fact recall part. So in this new progression, we are directing which times tables, which number bonds should be secure by when, and that is in the hope of making sure that children are secure as they move up into secondary school, and releasing their working memory, so that when they're working with very complex calculations, actually the bit about what's 7 times 8 isn't holding them up when they've got many steps to achieve. So within the progression, in P2, we will have secured our knowledge of doubles to 10, and we'll already have looked at the relationship between number bonds to 10, like 9 and 1, and also to 20, like 19 and 1, so a related fact, 9 and 1 and 19 and 1. And then to work on doubles to 20, tens frames and finger patterns, very helpful. So if we look at the doubles from 6 to 10, we can model that. If you look at those 2 tens frames there, we've got 2 nines, for example. So if we can model that the 2 5s that we see that are circled are making a full 10, and then they already know that double 4 is 8. So if we can visualize, if the pupils can visualize 9 as a 5 and a 4, which would be the same on regular finger patterns as well, then we can double the full hand of 5 fingers and double the 4 remaining fingers to give us 8. So 2 lots of 5 making 10, 2 lots of 4 making 8, so double 9 is 18. And with practice, those facts will stick without the visual, but it can be helpful to have various models of what the double looks like. You may or may not have Rec and Rec frames in your establishment. That's the abacus style resource at the bottom left there. Rec and Recs are particular in terms of they have 10 beads on each line, on each rod, but the 10 is split into 5 red beads and 5 white beads, and that reinforces in the same way as a 10 frame does, reinforces this relationship in partitioning single digit numbers into a 5 plus something. So on that Rec and Rec in the photograph there, you've got 7 on both of the rods, which is modelling double 7. And it's very clear for the children to see that they've got 2 lots of 5 red beads. So that's 10 red beads and 4 white beads. So it's just a nice visual for them to see how that works. In terms of the times tables, in P2, the 10s and the 2s have been introduced. And during P3, we're going to introduce the 5 times table, but also continue to practice those 2s and 10s, because as with anything, if we don't continue practicing them, if we leave them, then that knowledge and that familiarity and that fluency will not be preserved. But as we introduce any new table, we're going to reinforce the commutative law. So pupils need to be confident in switching numbers around in multiplication calculations, seeing that 2 times 5 is the same as 5 times 2. And if we are aiming for fluency in tables to 10 times 10 by the time they leave us in primary 7, which is 100 multiplication facts, if they've got that confidence in the commutative law, it makes it much simpler to retain those facts, because effectively they're almost halving how many individual facts they've to learn. So if they are really confident with that commutative law, it means that learning the 3 simplest times tables in terms of their patterns, so the 2s, the 5s and the 10s, is actually giving them access to over half of the multiplication facts already. So speed of recall is always still less important than conceptual understanding, but what we're trying to drive with this part of the framework is the fact that our fluency with multiplication table recall will enable that freeing up of working memory, so that, as I said, as they move up into secondary and are being asked to work with much more complicated problems that have multiple steps, they aren't held up with a sort of straightforward calculation that they could have memorized effectively. And what's good now is that we're lucky to have lots of digital tools at our disposal that give individualized practice. So you may still have SumDog available to you for classwork and homework. The rollout of Magma Maths platform is also providing lots of opportunities for individualized practice through the practice cards or assignments that you would set for the children. And there's any number of sort of practice games like Hit the Button there. So we do want to still avoid the negativity of like pupil versus pupil challenges or pupil versus pupil games, where it's very public and very obvious who has the speed of recall and who still doesn't have it. So still please avoid that, but we can really support the memorization of times tables facts through chanting and frequent recall practice and those individual practice methods supported by digital platforms. So moving on to calculation, we're going to look at the teaching points within addition and subtraction. In this block, we are going to use concrete materials to add and subtract with 2-digit numbers with no bridging. So we're not going to be exchanging at all or having to fitter around with concrete materials and turning our 10 from the Deans into 10 ones and things like that. Just the simplest, straightforward processes of combining the groups or taking away from a group. We've got 2 addition teaching points and 2 subtraction teaching points which mirror one another. And these are actually the same teaching points that appear in block 6 of P2. And that's true across the framework, that the first block of teaching of a new stage mirrors the last block of teaching and brings back concepts that were taught at the end of the previous year group. So it may not be the case in this first year of the new progression planners, but in future years, if the blocks have been followed, then block 1 should be a revision of something that has already been introduced before the summer holidays. So in terms of addition and subtraction, we've got adding 10 to a 2-digit number up to 89, because that takes our total up to 99, using partitioning, as we've mentioned, and then moving that very swiftly on to adding 2-digit numbers together using partitioning as well. And with the subtraction teaching points, it's the equivalent, so subtracting 10 from numbers and subtracting 2-digit numbers. And I'll model those through for you just now. So, in terms of the first addition teaching point, we can very clearly see with concrete materials what happens when we add 10 to a number. So they will already be familiar with building a 2-digit number with Dean's materials or with tens frames or place value counters, as we'll show you in a minute. So building 23 and then talking about what happens when we add a 10, they will very easily and quickly be able to tell you that that then means they've now got 33. Because visually it's very straightforward, and we can model with 100 square and also by writing the digit that we can see that the tens column has changed. The tens column's gone up by 1 because we've got one more 10. In the same way, if we're adding 69 and 10, they will very clearly be able to see that that takes them up to 79. And you can model this in the same way with tens frames by building 23, adding another full 10, and having them rearrange that so that it's very clear to them that they've now got 3 full 10s, 30 and 3. Or with place value counters in the same way, we've laid out 69 using 6 10s and 9 1s. And then by adding one more 10, it's very clear to the pupils what's happened. We've added one more 10. That's why the tens digit has increased by 1. We've gone up from 60, from a 6 to a 7. So then with that learning very quickly recapped, we can move on and start adding two 2-digit numbers together using these methods. So we're building our 23, building our 14, and rearranging these materials so that it's very clear to them how many 10s they've ended up with and how many 1s. And remembering that for this block, we're not entering into bridging. So these calculations must always be a number of 10s and a number of 1s that don't exceed 9 so that we don't have to exchange at all. So by doing that, we find we have 37. We could equally model this with place value counters, laying out our 23, laying out our 14, and being able to clearly see that total as well, or lay it out with tens frames, 23, 14, and having them rearrange that so that they can very clearly see that they've got 37. So whichever materials lend themselves best or that you've got most available to you in the classroom, and again, as I said, digital versions of these equally very useful if that suits the pupil's needs more nearly. So there are examples of the MathSpot QR codes. As I said, the very last slide of this presentation is a full A4 slide page, which also is in the resources as PDF for you to print. They have on tables and caddies, whatever, so that they can scan whichever manipulative they need to go straight to for your teaching. So in the same way, if we move on to the subtraction points, we've got the same process again, but modelled through for subtraction. So laying out our 33, and if you are familiar or have seen the Primary 2 webinar, we talked about the fact that when they've been working on addition, there is a misconception that they will need to lay out the 10 as well, because they've just been building two groups to put together for addition. They will want to make the 10 as well, but we need to be clear that this is a taking away, it's a removal of a 10, and worded scenario is really helpful for that. So talking about, we've got 33 children in our class, 10 of them go off to get an injection, and we are left with what? So we need to give them a place to put that removed item. So either putting it in a marked place or on a different whiteboard, a different section of the table, or ideally actually just removing it from the tabletop completely so that it's very clear to them that they've only got 23 left. In the same way here, 79 people go to the cinema, but 10 of them leave halfway through because they don't like the film. How many left in the cinema? We can pull the 10 away or ideally remove it completely from view so that we can see there's only 69 remaining. And as I said before, again, we can model this through with tens frames. Here's our 33. We're going to take 10 away, remove it. That's leaving us with 23. Or we can do it with place value counters. Same thing again. We're going to take 10 away, and subtract it, remove it, and that's going to leave you with 69. Okay? So in the same way then, we can move them on to subtracting double-digit numbers from double-digit numbers where we've got to work with tens and ones. And in the same way, they're going to lay out the first number, remind them they don't need to make the 14 here. We're going to be taking 14. So we're not adding another 14. We're going to take it from this existing group. And that means that we need somewhere to take it to. So we're going to remove 10, 1 10, and 4 ones, and ideally remove them completely from view so that they can see very clearly they've got 23 remaining. And again, reminding that we don't need to make exchanges. So when we're providing children with calculations to trial, we must offer calculations that don't require an exchange. So in the same way, we could model it through with place value counters, taking away that 14, completely away from view, or tens frames. Here's 37. I'm going to take away 14. I'm going to take away these 4 here and one of the tens. Away they go. And I'm left with 23 as well. And again, those manipulatives are available on MathSpot if that's more useful for some pupils. So moving on to multiplication and division, we have 3 teaching points in this block for multiplication and division. And you can see that they link to some of the skills we've mentioned already. So we're going to be looking at multiplying by 2, and we're talking about the commutative law, and we're going to look at doubling and halving, and obviously that relates to multiplying by 2 as well. So in our first 2 teaching points, we are wanting to build on the recall of the doubles that we know already and the 2 times table that we have learned the stations of and been counting up through in primary 2. And because we've done that, we can now be quite confident in the fact that children should be able to read a calculation like that one there as 2 groups of 14. So if they know that that means, and we can model that that means 2 groups of, 2 times 14 means 2 groups of 14, then we can build 14 2 times. So here we've got 2 groups of 14. And this is very much related to those methods we were just using for addition and subtraction. They can then very quickly combine those and see they've got 2 tens, 20, and 8 ones, 28. So something like 2 times 14 is far beyond the 2 times table stations that we've learned, but they already have a strategy to have a go at it. So we're nowhere near moving on to column multiplication yet, but we do have a method here to be able to attempt double-digit multiplication, because really what we're talking about here is repeated addition, which they've already encountered in P2. It's important to make sure that we're limiting it to not too many groups, because then we get mistakes made. So if we made that 8 times 14, we'd get mistakes made in terms of counting the total. So here it's more important that we're reinforcing that concept of, well, if it's 2 times 14, I need 2 groups of 14, 2 lots of 14. And as we do it, we're going to be reinforcing that commutative law as well. We can model it through with place value counters. Here's 1 group of 14, 2 groups of 14. how many do we have altogether? We can model it through with tens frames as well. Here's one group of 14, here's another group of 14. How many do we have altogether? And in any of those visualizations or modelings, they can very clearly see how many they've got altogether. And for that third teaching point, we're going to build on the introduction of part-whole models that they've seen in earlier stages for multiplication and division, so for doubling and halving only at this stage. So we move through from, we could have physical objects laid out in a large format bar model. If you drew that up on your board and stuck counters up on it or drew dots in it, that's fantastic. And then they can move on to using numerals within it if appropriate. So again, we've got our recall of doubles and our 2 times tables, and we've just been doing repeated addition for multiplying by 2. So this is a step on and it's related. So if we do want to double 32, we can do it the way we've just done, or we can model it through with a bar model in this way. So here's 32. I know that I want double of that, so it's 2 parts, and I'm going to make the 2 parts come together. So I've got 30 here and another 30, 2 and 2. So I've got 60 altogether in the tens and 4, which has given me 64 as the double. And like I said, they could move on then later to having numerals within a cherry diagram or a bar model as shown. And as we move on to fractions, decimals and percentages, which is our last core number topic for this block, you can see that the second teaching point here really relates to that doubling that we've just mentioned. So, as I said at the beginning, the core number topics, right through to fractions, reappear in every block of the progression. So through your teaching of primary 3, you're going to talk about fractions 6 times in the 6 different blocks. Now, that's really important that we've got pupils who are familiar with talking about fractions and that it's never left for longer than that, so that when they go up into the next year group, it's not been 2 terms since they talked about fractions, or 3 or 4. We want to make sure they're revisited concepts frequently and built on as the skills progress. So, in terms of the first teaching point then, we want to give the pupils the same facility with fractions as they have with whole numbers, and that means doing lots of the same number sense type activities so that they also have fraction sense. So counting routines are really important here, and we can use counting routines so that they get the idea of the number word sequence in terms of halves here, so 1 half, 2 halves, 3 halves, and then build on that ideally with some sort of visual or physical representation so that they can clearly see as they're adding another half, they're creating wholes. So you can build on that and move the number word sequence on from 1 half, 2 halves, 3 halves to saying 1 half, a whole, 1 1/2, 2, 2 1/2, 3. And these are new number sequences that they can embed and get used to. And this is true across all of our areas of mathematics. We need to be able to count in increments of 10 pence, increments of 100 millimeters, increments of 15 minutes, so that we understand all of the different systems that are based on number but have different idiosyncrasies about them. Yeah? So we build on this and make sure that they're very familiar with counting up in halves, and in the same way they could do that with quarters, or you do as they move on with any type of fraction, 1/4, 2/4, 3/4, a whole. And this kind of counting and familiarity with halves and quarters will set them in really good stead for block 2 when we're moving on to teaching points around time. We don't have time in this teaching block, but we will visit it in the second block of teaching for P3. So as well as that counting routine, the second fractions teaching point is using sharing strategies to find half of a quantity. So very familiar division strategies here, which they will have encountered in primary 2, but they might have encountered it in terms of 8 divided by 2, so 8 shared by 2. So we need to make that link that half is making 2 groups. So we're dividing into 2 groups. The first photograph there is showing a concrete version where we've got cubes. We've counted out 8 cubes in readiness for doing the sharing. So they've got 8 laid out on their tens frame at the left there. And then they'd be sharing into those sharing circles, dishing out those cubes fairly, one to each circle as they moved on. And then the visual, the pictorial representation of that underneath is a common dotting strategy where they would have drawn the 2 circles and then counted up to 8, crossing into each circle as they went. And hopefully for some children, because we're working on doubles and their related halves, they will start to see and become familiar with finding half of a quantity using their doubles if they can, and using their partitioning skills if it's a larger even number, so that actually they may move on to mental strategies and abstract strategies for that. They could also use the bar model that we were just talking about, and it's very helpful to use concrete examples with a bar model as well to bridge that concrete to abstract strategy. So this is the inverse of what we had a moment ago. Half of 64, we'd be sharing out our 10s, 1 for you, 1 for you, 1 for you, 1 for you, 30 each, and then sharing out our 1s as well. And we can then very clearly see that it'd be 32 would be half. Yeah, and you can talk then about, so double 32 is 64 and so on. So moving on to our beyond number topics, in this block we've got teaching points around shape and space, and we've got teaching points around information handling. As I said, core number, all of those organisers we've already discussed. The core number organisers come in every block. Shape and space appears in block 1 and block 4 for every year group, and information handling, which we'll see in a minute, appears in 4 of our 6 blocks for each year group. They are mirrored across year groups, so block 1 of P2 has shape and space, block 1 of P1 has shape and space. All of the block 1s across every year group have shape and space. So if you would stick a pin through a pile of the annual overviews, you would find the same block and a mini progression across the year groups. So in block 1 here, for shape and space, it's really centered around 2D shapes. You would find 2D shapes in block 1 of any year group. So as we look at the teaching points then, we're looking at naming and being able to sort 2D shapes by their properties. In primary 2, we've introduced the family of regular shapes. And so we should be familiar with the fact that regular shapes have equal sides and equal lengths of sides, I should say, and equal angles. And so we should be able to be confident with the fact that a rectangle is not a regular shape, that it's a special quadrilateral and it's very interesting. And just in the same way, a right angled triangle, which we're introducing in primary 3 here, is an interesting shape, but they are not regular. Okay. And moving on from that, we are also looking at symmetry. And really at this stage, and up to primary 4, we're just interested in one line of symmetry, but the progression in the blue box there is just showing how we're moving from concrete, even physical 3D type models, where in primary 1 we might be making symmetrical blocks with symmetrical models with building blocks, or making butterfly pictures and that sort of thing, and then moving up through the primary stages. By the time we get to P4, we're very much in the world of 2D shapes that we're then looking at with mirrors, or identifying the other sides of in that way, and we're expecting more precision. So as they move up, it's important they have different types of activities, different types of provocations to engage with, all building on that symmetrical knowledge. We're mentioning tiling for the first time in primary 3, explaining that when shapes tile, they fit together exactly in a repeated pattern with no gaps, and there's lots of lovely IDL opportunities lending itself to investigations or linked to expressive arts, or looking at tiling in action, if you like, around in our environment or in architecture and things like that. And then for directional language in primary 3, we are interested in the terms of clockwise and anti-clockwise. They already have familiarity with an analog clock face from primary 2 and primary 1, so we're going to be building on that knowledge there. In terms of the type of questioning, we're looking for them to be able to engage with problems like the one at the bottom left, or in the speech bubble there, walk forward 3 paces, turn a quarter turn anti-clockwise, walk forward 2 paces, etc. So half turns, quarter turns, full turns. You can see this links to the halves and the quarters that we had in our teaching points for fractions. And I would encourage you to explore digital opportunities with resources like Bbots if you have them in school, or online coding type platforms like Scratch or Logo. If you need more information about that, then we'll be able to help through collaboration on the MS team. And the final teaching point for shape and space, which also appeared with the 2D shapes on an earlier slide, is to get familiar with right angles. So we're introducing right angled triangles in this block. They also need to become familiar with the fact that a right angle is 90 degrees and that it looks like a familiar angle, and they will find them all over their environment. So angle hunts are a great option, noticing where there's 90 degrees and unpicking that misconception that it's not because it faces to the right, being able to spot examples of right angles that are in all sorts of orientations, and I think making that link between right in terms of correct or exact, because that is where the term right angle comes from. I think it's related to Greek architecture and perpendiculars and things. It's not to do with facing to the right or the left. Okay, so then finally, in terms of information, data and uncertainty, we just have one teaching point in this block, which is asking the pupils to read information from a range of data. So looking at tables, tallies, bar charts, pictograms, questioning of the type which is most popular and how many of a particular category were recorded, etc. So really focusing on the core reading of data points rather than any comparative questioning at this point. So a couple of examples here, which you might recognise from our universal assessments that were aligned to the Glasgow Counts trackers. The questions are still really useful, so even if you're not using those as assessments, I would encourage you to look at those assessments as sources of examples for questions. In the left-hand example, you've got records of number of cars recorded of different colours, so we would be asking things like things that are recorded in the questions below, but I would encourage you to consider presenting data as a goal-free task, certainly as a starter or a number talk, just displaying a data table, potentially like the one with the pets there, and asking the pupils what they can tell you. And tasks like that have been really advocated by the mathematics team at Education Scotland in the last few years in terms of providing a self-differentiating task, in terms of all pupils being able to access that and being able to tell you something. Somebody might say, there are tally marks in this table. There are 4 pets that you could choose from, or there were 4 types of pets owned by this pupils in this class. Others might start telling you which are the most popular, or how many more dogs there were than cats, etc. So it's quite interesting to just provide data, and goal-free simply means there's no direct questioning. You could then go into questioning once the pupils have explored the data on their own, but it's a really good skill to actually look at information and ask, and pupils ask themselves the question, well, what do I know from this display? And I would say it's related in terms of a skill to what we talk about when children are doing reading comprehension. When we're asking children to engage with a text that has questioning with it, we will always say to the child, read the whole text first. We discourage reading the questions and then searching for the answer without having an overview of what the text is about. We want them to read the whole text first. Well, we can approach data in the same way. Any data display is listed in the literacy benchmarks as a text type. So they need to look at the data display. What do I know? What's the whole picture here? And then engage with questions. Actually, what are you going to ask me about it now that I know what I'm talking about? Yeah, so that's really an interesting perspective, I think, to take. So that's us got to the end of the walkthrough of the teaching points for this block. Please leave us any feedback you have from this webinar or about the progression planners in general. As I said at the beginning, it is a 2-year implementation of these new progression planners. We're aware that new curriculum information is coming out from Education Scotland in that time frame. There will need to be changes, so all your feedback is really welcome and necessary to make these as best they can be. We'll be putting out information about those end of block assessments early in the new term. Those are in development at the moment. And then you will get dates on CPD Manager for Block 2 webinars in the same way as we've done these Block 1s. So any questions or queries, you can contact us through the Microsoft team or direct to my email that's sitting there on this slide. Then the last 2 slides here are just some useful links and the QR codes I mentioned for MathSpot, which you could print and use as placemats in your table caddies if you find that useful. I certainly found it useful in my upper school classroom where concrete resources were a bit more scarce, let's say. So thanks very much for listening. Please keep in touch and we would love to have your feedback. Many thanks.